Now that we have talked about what changes we need to make to our traditional workflow, let's see how we can implement everything we just talked about. We will first create a data ingestion and validation component as part of our training pipeline. Let's now see what this component will do. These days, most data lives on a data lake. We will also have a training data on an S3 bucket. Our component will load the data from the S3 bucket and then it will check the data for the assumptions that we might have about the data, validate it, and then store it back to our data lake. But the main question is, how will our component validate the data? We will use Pandera, a Python library for data validation. One can also use Great Expectations, which again is a Python library for data validation. We will first briefly look at how we will set up our coding environment, then look at how Pandera works, and finally create our data ingestion and validation component. Let's now talk about how will we build our data validation and ingestion pipeline. But before we do that, let's look at what kind of ML code we have that we need to break into different components in a training pipeline. So this is an example of a prototypical code that you might get as an MLOps engineer or an ML engineer that you might want to convert into a training pipeline. Now the code that you might be given usually may not be written using great coding standards. You might get a lot of Jupyter notebooks, and from those notebooks you'll have to create some kind of a training pipeline. So here is an example. This is a very simple prototypical example demonstrating that there is an ingestion going on, there is some feature engineering that is going on. Finally, there is model training and model validation after it has been trained. Now we will break this code into different components, starting with data validation and ingestion component. Now, one of the things that we discussed earlier was that our data is on a data lake somewhere, and if you belong to AWS world, the data lake is usually built on an S3 drive. So here I have an S3 bucket on my S3 drive. This is a private bucket, and I have a data lake over here where there is raw zone, and this is where my ingestion pipeline is going to pull the data from. Usually this part of a data lake is maintained by data engineers who maintain data pipelines and provide data for training. I also have a landing zone, and this is where, after doing data validation, my very first component in the training pipeline is going to put the data back to. So let's see how will we do data validation. I'm going to use a Python library called Pandera. And let me just show you what does it mean to validate data. If you look at my training data, which I've just ingested from my data lake over here, you can see I have several columns. Now there are a couple of things that you might want to validate when you're building your training pipeline. One of the things you might want to validate is, does it contain the same column names which were used in building your original training pipeline? Do the columns have data types that you expect? Is the number of adults column integer column in the data that you are currently validating and that will be used on downstream training tasks? So let's see how the validation code can be built. So I will show you one example of how you can write your validation. So if you've ever worked on a backend framework such as Fast API, this will look very familiar. This is very similar to a Pydantic kind of data validation. So basically you will create a class, and within the class you will define your rules for validating different columns of your particular data frame. So I am inheriting from pa.dataframe model class, and then I'm sort of talking about what are the columns I have. So here I have done validation on two columns. There's an ID column, and I'm saying this will be an integer column. There's a number of adults column, and I'm saying that I should expect this column to be of type integer. Let me create this validator, and now let me try to validate my train data. So all I will do is I will take this class that I've created, and I will give my training data frame as an input to it. In case there are no issues with the validation, it will not raise an error. But let me change the validation a bit. Let me say that I expect the number of adults column to be a float column. And let me recreate this class and then try to validate. And now you can see it raises an error. So in this way, I can create rules for all the columns that I have on their column names, on the data type, and try to do the validation of any new data that I might get to train my training pipeline on. And in case my training assumptions are not met, there will be an error because of the data validation component that I've put in. Let me move it back to int, and let's again try, and this works this time. So what you can do is you can create a fairly robust data validation strategy using Pandora. And here is an example of what I have done. For each of the columns in my data set, I am very explicitly writing down my assumptions about the data type. Are the columns expected to contain null values or not null values? And then I have some custom checks as well. For example, in the number of adults column, I don't expect to see values greater than 4, and I'll put a check here. In the type of meal plan column, I don't expect to see values greater than 3, and I'll put a check there. And similarly, I've created a data validator for my test data, which inherits from my trained data. The only difference between test and trained data usually is that there is one column missing in trained data, which is the column for which you're training the model as target variable. So I'm saying, okay, everything from the schema train remains, all the rules from the schema train remains, except for the column booking status. And I can very succinctly define validators for my train and test data. Let's check if they work. And again, if I take my schema train class and provide my train data, I can see it will work. And for my schema test also, if I supply my test data, I can see it is passing the test correctly. In case there is any change in data which is not quantified in terms of my assumptions in my validator, it will raise an error, and hence I'll know that there is something wrong with my data. Next, let's see how to integrate all of this and create a model ingestion and validating component. Let us now see how will we create our data validation and ingestion component. So what I've done is I've created this project on my local file system, and I've created this folder called data validation. And within this, all the code relevant to this particular component will go in. One of the very first things I'll do is, since we need to maintain some kind of version control in terms of what Python packages, what Python versions are used, I'm going to create a file called conda.yml. And within this file, I'm going to put all the Python dependencies that are needed for running this particular component. And after you have created this file, you can go inside this particular folder. Let me move it here. You can go inside this particular folder and simply run this command, conda and create -f and conda.yml. If you run this, it will create a Python environment whose name will be data validation. I've already done that. So I'm just going to activate that environment. I'm going to say conda activate data validation. And now I have the relevant Python dependencies to build this particular component. Let me also create a new file called utils.py. And in this particular file, I'm going to keep the data validation components that I discussed in an earlier video. We discussed this schema train and schema test validator. So I'm going to put them in this particular file. And finally, what I'm going to do is save this file and create a new file called run.py. Let me put it inside the data validation component. This will be my main file, which I will run to execute the logic for data ingestion, validation, and finally writing my data back to the S3 drive. Let's see how will that work. Let's make some imports and let me write down those imports. So you can see from my utils.py, I'm importing the schema test, schema train, I'm importing pandas to read my data from the data lake. There's a logging module also because I might want to log out where my current program is in terms of its execution. And I'm going to use this argparse module to create command line arguments so that I don't have to hard code the paths of the train and test files for this particular component to run. So let's first create these command line components. So this particular component will accept 3 command line arguments. One is the train path, test path, and the landing zone path. From the train and test path, it is going to pull the data from the raw part of the data lake. And landing zone is the path where I will put my data after validating. Just to refresh your memory, you can see this was my data lake. There is a raw zone where my current test train data is kept. I need to validate it and then I need to put it back in the landing zone. So landing zone path would be this, and train test path would be the path to these 2 files. So after I have my command line arguments, let me create my main function. And you can see what is happening over here. I'm using the logging module to tell at the very outset where my program is in terms of its runtime. I first inform the user that I'm reading the train test files. The paths are coming from the command line arguments, which I defined over here. Once I read the train and test data, I do data validation on it. In case my data validation fails, I raise an exception and this will stop my program. Similarly, I validate my test data. In case it fails, I raise an exception and my program will stop. After I have finished validating my data, I am going to create the train and test path on the landing zone. For that, I'm using the OS module to join 2 subparts of a particular path. I'm going to name the validated file again as test.csv and train.csv, but this file now will be written in the landing zone. Finally, I will write both the train and test files to the landing zone, finishing all the tasks that are required of this particular component. Now let's see how will I run this component. Now for your convenience, what I've already done is I've created a repository with all the relevant code. You can see there is a subdirectory called part 2, and in that there is this data validation component, and there are also instructions on how to run this particular component. So let's see how will I run this data validation component. I'm already in the data validation folder. I've already created my environment. I've already activated my environment. All I will do is just copy this particular command and I will paste it over here. So you can see the first argument is train path, and I've given the train path. Then there is test path. Then there is landing zone path. And these are being used by my script to do the relevant things that I wanted to do. Let's hit enter and see what happens. So you can see my component read the train test files, validated them, and after it passed the validation, it wrote back those 2 files back to the landing zone. Let's check our S3 drive to see if that is what it did. Let me go back to my landing zone and see the date modified. So you can see the time is 12:11 and it has just written them back to the S3 drive. So this closes our discussion on how to create a data validation component. In the next video, we will create a feature engineering component.